So let's go ahead and start the Unit 3 guided practice in your remediation practice. Looking at weight versus mass, it says, what is the difference between mass and weight? Mass is the same no matter where you are in the universe, and weight is a measure of the pull of gravity on mass. Number two, it says calculate the weight on Earth given the masses below. And so, for the sake of mass, we're going to say that gravity is 10 meters per second squared. When we're looking at this, we have a 50 kilogram object, and so we know that our force due to gravity equals our mass times gravity. So 50 times 10 is going to give us 500 newtons, and that would be our weight. When we're looking at 120, and this says grams, it needs to be in kilograms, so this would be divided by 1,000. 0.120 is going to be kilograms times our gravity, which we're saying is 10. It's really 9.81, but for math's sake, let's round it to 10. So 0.120 times 10 is going to give us sorry, not 12, but 1.2 newtons of gravity. And then lastly, we have 800, so our mass is 800 times 10, so we have 8,000 newtons. Looking at our next one, it says, what is the mass of an object when the weights below are measured on Earth? Gravity is 10. So we have our force due to gravity equals our mass times gravity. And here we have our force, so to find our mass, we just go ahead and divide our force by gravity and we'll get mass. So 1,200 newtons is going to be 120 kilograms because it's 1,200 divided by 10. 500, and that K means kilonewtons, so that's really 500,000 newtons, all divided by 10 is going to give us 50,000 kilograms. And then 400 newtons, go ahead and divide that by 10 and you get 40 kilograms. Number 4, it says give conceptual examples of Newton's laws of motion. So our first one, the first law of motion is the law of inertia, meaning that objects are lazy. So if objects are at rest, they're going to stay at rest. But object in motion, they're going to stay in motion. And so a conceptual example of this is that a car that is moving, even though you let off the accelerator, it still wants to move forward. And the only reason why it stops is because of friction, or you apply the brakes. But if it wants to keep going forward, it doesn't want to stop. And then you can think of an object at rest, so just a large rock sitting there. It wants to stay at rest, it won't move. The second is just relating force and mass. So force is proportional to mass and acceleration. And so when we're looking at these two things, when something accelerates, we know that a force has to be applied to it. And then lastly, we have our law of action reaction, that if you apply a force to something, the same force is applied back. So if I push on a wall with 100 newtons of force, the wall pushes back on me with the same amount. So in the next one, it says use Newton's law to calculate the unknown variable. So when we're looking at this, we have a 2.5 times 10 to the fourth, and that is gram object. And remember, we deal with kilograms, so we'll go ahead and divide that by 1,000 and we will get 25 kilogram. Object accelerates at 1.4 meters per second squared. And so when we're looking at this, what's the force of the object? All it force is force equals mass times acceleration. So 25, all we're going to do is go 25 times 1.4, and we get 35, and our unit for force is newtons of force. Next, we have a skater A is 80 kilograms, exerts a force of 100 newtons on skater B, which is 25 kilograms. What is the acceleration? So we're looking at this, and we know that acceleration is force all divided by mass. And so when we're looking at this, each skater is going to feel the same number of force, that action reaction. So 100 newtons divided by 80. So 100 divided by 80. So for skater A, will accelerate 1.25 meters per second squared. And then skater B will be 100 divided by 25 and will have an acceleration of 4 meters per second squared. Now in the next one, it says, what is the mass of an object that accelerates at 2.5 meters per second when the force is 200 newtons? So think about your equation. Force equals mass times acceleration. That means that mass equals force divided by acceleration. Go ahead and solve that one out and see if you can get that one. The next one, it says draw and label a free body diagram for a car moving down the road at a constant velocity. So here's my car represented by a dot. Draw an arrow, which is the same length as that arrow, which is same length that and that. And so we are at all the arrows are equal, or they're supposed to be equal. We're saying that they're equal, and so therefore it's moving at a constant velocity. Remember that constant velocity in a free body diagram is the same as an object. It looks the same as an object at rest. Basically, all the forces are at equilibrium, and all the forces are equal. B, it says a marble accelerating down a ramp. And so what we have is we have a ramp, have our marble. And so what we will show is that the arrow of acceleration should be greater going down the ramp than the friction pushing it back. So it'll have a free body diagram that looks like that. And then an elevator accelerating upward, so it's going up. So the arm should be greater going up then going down. Looking at friction, it says use the friction equation. So our friction or our force due to friction will equal our force, our normal force times the coefficient of friction. So on our first one, it says a box is pushed with a force of 200 newtons at a constant velocity. What is the coefficient of friction? And so therefore it's 200 newtons of force at a constant velocity. That means that 200 newtons is the force due to friction, and we're going to say that it's a 10 newton box. So our normal force would be 10 newtons. So our force due to our force due to friction equals the coefficient of friction times our normal force normal. And so to find this, we're saying it's a 10 newton box, and we just take our force due to friction, which is 250, and divide it by our force normal, which is 10, which gives us a coefficient of friction of 25. The next, it says that a 2 kilogram ball rolls on a flat surface with a coefficient of friction of 0.22. So all we do is we take our 2 kilogram and we say, well, its weight or its normal force is just the opposite of the weight. So we're going to say that's on Earth. So it has 10 meters per second squared is the acceleration due to gravity. It's a 20 Newton ball. So force due to friction is our 20 Newton ball times the coefficient of friction, which is 0.22, and we get an answer of 4.4, which is friction. Go ahead and try C on your own. Looking at ramps, it says draw a free body diagram for all of the forces acting on the box that is motionless on a ramp. So we'll draw a ramp. Yay. Box represented here is the dot. And so our normal force is perpendicular to the surface, which should be there. It's sitting on the box. But remember, gravity is perpendicular to the surface of the Earth. And so it would draw gravity pulling straight down to the surface of the Earth, which is right there. Looking at torque, it says use the torque equation to solve for an unknown variable And our force due to torque is just going to be basically our mass times the distance from the lever, or the distance from right here. And so when we're looking at this, since this is not moving, this is not turning, so therefore it has to be the same distance, and they are, because they're on the same notch. So therefore it has to be the same mass, which is 5 kilograms. When we're looking at torque, torque produced when 50 newtons of force is exerted on 0.5 from the pivot point. So our torque is going to equal our 50 newtons, and it is 0.5 meters from the pivot point, which is going to be just 50 times 0.5, which is going to be our 25 newtons of, or 25 of our torque. And then lastly, it says, where can a mass be placed in order to balance the system? When we're trying to balance it, remember that you want the same amount of torque on each side to get it balanced. So think about how much torque this is exerting, how much torque this is exerting, and where we would place another weight to make it balance out.